statistician is the person that works with numbers.
You are amazing, Kai. That is an absolutely amazing drawing and an amazing guess of itself. Today's topic, as you probably already guessed, is statistics. Kai just said that statisticians work with numbers, and he's right. So what is statistics? Let's talk about what statistics is. So statistics is a way to use math to study and understand data. So what statisticians do is they convert data into numbers. So we can turn our data into lots of different types of numbers that tell us different things about our data. So we can use statistics to learn about things like how many of things we have, how often things might happen, how much of something we have, and also how likely something is to happen. So how likely is it that when I go for a walk today, I might trip over, right? A statistician might calculate that using data and converting it into numbers. So what exactly does a statistician do though? So a statistician does a lot of amazing stuff. The very first thing we're going to talk about is that they help solve all types of problems. And how do they do this? They do this by collecting many different numbers of all these things, and they try to see patterns in these numbers. And a pattern is how many times something repeats itself. For example, I keep seeing the color of red on all the markers I have. I have a lot of red markers. That's going to be a pattern. Following that, they also make discoveries in many different fields. So statisticians, they actually are in many fields, not just math. They are definitely in chemistry and medicine. They work with doctors. They work with scientists. They even work with people that are in charge of money, like bankers. And lastly, what they do, they summarize, which means they put all the information they learned into a very, very short explanation. And then they described what was going on in a certain group of population. Remember when I told you guys about patterns? How sometimes things pop up a lot more than what you think. You're like, I feel like I've seen you before. That's their job. They get to see all these big groups, and then they get to see little patterns that happen. Like collecting data or data, whichever way you like to do. So collecting data means gathering information and numbers to study. So what these scientists do is they get all these numbers, right? Because they can't just get one person's opinion on something you're trying to figure out. If you say, do you like ice cream? Somebody might say, I don't like ice cream. That doesn't mean everybody doesn't like ice cream. That was just one person. You need to collect 100 people's information. 100 people like maybe 50 don't like ice cream and 50 do. And now you can see a pattern with all these numbers of people. Next, they collect data by counting, measuring, and even asking questions. Like, why do so many people not like ice cream? Is it a pattern? What type of ice cream they don't like? So these are very important parts that these scientists use for collecting data. And we're going to learn a lot about collecting data with this nice short video that we have right here. Yep.
Data collection. In our daily lives, we often come across...
So what we're going to do is we're going to collect some data on pets, okay? We're going to collect data on pets. So we're going to find out how many of us have a dog, a cat, a different kind of pet, or no pets at all, right? We're going to do it right now. So my first question is, who has a dog? Okay, so Miss Andrea has their hand up. So we have one person who has a dog. So we're going to add a 1 to our table right here. Who has a cat? Miss Jess has a cat. Andrea, do you also have a cat? No? Okay. So only one person has a cat. Miss Jess has a cat. So we're going to add to our table 1. So what we just did there was we collected our own data. Isn't that really cool? So you guys are all statisticians right now. Very cool. Because like all amazing scientists, we have to analyze our data. So by analyzing our data, what I'm trying to say exactly is looking for patterns. And like I told you guys, a pattern happens over and over and over again. We can also analyze data by making graphs or charts to help us see it. Because it's hard to follow the table, right? It's a lot of numbers. It's too much. Sometimes it's so much easier to see a picture, right? Like when you read a book, do you want to see some pictures while you read the book, right? To imagine how the characters look like. You don't want just like words in a book. How can we analyze the data we have that we collected on pets?
Maybe that could help you remember. That could help you remember by when you do the graph. This is how you could like examine it. Like you could see there is like let's say there's 10 mangoes in a tree, and then there's 8 blueberries in a bush.
Amazing response. Absolutely right, Luca. We have to make sure to draw these into graphs. So let's watch a video to see more about graphs.
Today, we are going to learn all about graphs. Graphs can show percentages, pictures, bars, or lines.
We're going to make our own graph. So this is our data here, look, on the right. This is the data that we just collected. Pretty cool, right? So this is our data, and now we're going to make a graph out of it with your guys' help. Where should we start? What should we do first, WonderKids?
We should write the names of the pets, like dog, cat, other no pets.
We made our very own graph with data that we collected today. Woo! Can I get an emoji?
So talking about biostats, today we have a very special guest, which will be Mr. Eric that is here with us today, our very own statistician.
Hi kids, how are you all doing? So as Miss Calcio said, I am a statistician or a biostatistician in particular. So what do I do? So what is my everyday role? I do several things. I wear many different hats. One thing that I do is I teach. So much like how all of you go to school and learn different topics and fields like math or science or reading or English, I teach biostatistics to many college kids who are interested in either learning about it or learning and how to apply it to their own practices. Something else that I do is I help develop new tools to solve some really hard problems, right? So as you can imagine, data can be as big or as small as you want it to be, and we always need to find better ways to analyze data, whether it's to make it faster or to analyze it better. And part of my job is to help develop these tools. And then the last thing that I do, which I think is the coolest part of my job, is that I actually help other scientists with their cool problems. So I work with a lot of people, with a lot of doctors in particular, who are studying certain diseases or who are interested in looking at specific type of outcomes. And these are problems that they can't solve on their own. And so they come to me to sort of help them with their sort of data analysis. So what can we do with biostatistics? I know Ms. Andrea and Ms. Calcio went over this a little bit with you all right now, and I believe yesterday. But just a quick recap. Biostatistics can help us answer a lot of different questions, especially those in sort of like the sciencey fields. So these are questions that can be something as simple as, do students like cats or dogs more? I think this was something that you all sort of did yesterday, or this small exercise you did. Another fun thing you can do is you can ask what is the most common favorite flavor of ice cream, right? We want to see how many different flavors there are, if there's a clear winner or if it seems to be tied. And then we can, have some more bigger problems we want to solve. For example, you might want to answer the question, how many students were sick last year, right? So a lot of kids get sick with the flu or with a cold, especially during the winter time because it's really cold and chilly outside. And so you might want to see just how many students were sick over the past year. And if we have data across several different years, then we can kind of see if it's the same number of students, or if it's increasing, or if it's decreasing or getting smaller. And then a little bit more of a complicated problem we could answer, sort of tacking on to what we just talked about, was seeing how many students were sick last year because their parent or their sibling was also sick. And no matter what question we ask, whether one of these four or many other really hard problems or questions, in order for us to answer these questions, we need data. Data is really important. Without this, we can't make any sort of conclusion. And so we need to collect data, specifically data that's pertaining to the question you want to answer, and then find ways to sort of analyze this data. So a biostatistician, I think one way I like to describe my job is it's like being a data detective. So I'm essentially solving problems or solving mysteries, but instead of using a magnifying glass and looking for footprints and fingerprints or anything, I'm using math and numbers to sort of answer these questions. And so typically, the way sort of biostatisticians kind of play a role into answering these questions kind of goes like this. So the first thing is that scientists might have some question that they want to answer. So it could be something as simple as how many students were sick this year or in the city of Los Angeles, and they want to answer this question. In order for them to answer that question, they need to collect data, right? So you need to go around and ask everybody you see, or however many people you can get, whether or not they were sick, if they knew someone else who was sick, and you need to record basically all this information on them. It could be where they live, it could be if they got sick, yes or no. There's a lot of different things we can collect on every individual. And once we collect all this data, we then need to analyze it, right? We need to basically take this data and sort of make sense of it. That's where the sense of data analysis comes into play. After we analyze the data, then we have some result, right? We have a conclusion that we can draw based off of our analysis. And hopefully, based off of that result, we could go back and answer the question we were trying to answer in the first place. And then lastly, I just wanted to kind of say, if you think you want to do biostatistics, or if you think you like statistics, here's kind of a good way to know if you may or may not want to do it. This is sort of what I got when I started doing this, when I started becoming a statistician, is you might like being a biostatistician if you like math. So if you like math, that's already a really good sign. You might want to do statistics or biostatistics in the future. If you enjoy puzzles or solving problems, that's a lot of what we do. If you enjoy, playing games or video games or card games or any of this stuff, that's also a really good trait to have, because all those things kind of help you or force you to solve problems, solve these puzzles and stuff. And so I kind of feel like when I got into being biostatistics, a lot of it was coming from the fact that I really enjoyed playing video games, and I really enjoyed solving problems, and kind of doing that for my job was really cool. And then the last thing I wanted to talk about, kind of like this quote that comes from a very, very, very famous statistician, very wise old man, John Tukey, is this is what he said about the field, which is that the best thing about being a statistician is that you get to play in everyone's backyard. And I have, as you can see, many hats here, because I like viewing this as wearing a lot of different hats when I do my job. And it's probably the best thing or the coolest thing about my job, which is that, because, I do biostatistics, I'm able to learn a lot about a lot of different fields. So I'm not a doctor, but I have some really cool, really smart doctor friends, and I learn a lot about, the flu and the cold from them. I have a lot of other cool doctor friends who do a lot of work in terms of how your heart works, and how we can use sort of information about your heart to sort of help your health later on. And so I learn a lot about the heart. I learn a lot about your body, or my body itself, and it's just really cool, because I wasn't trained in that. I didn't go to school for that, but I'm able to learn a lot from them.
Okay, so what we're going to do is we're going to do some more data collection. Let's go ahead and open our M&M bags. You can open both of them and empty them out onto your surface. So go ahead and organize them by color. So I have my blue organized, I'm putting my reds together, I'm putting my yellows together, and so on.
I have 10 blue M&Ms.
Amazing. Could you tell me how many brown
I have 4 brown.
and green
I have 5 green.
and orange,
8 orange.
8 orange and red?
I have 1 red.
Hand it back over to Dr. Eric, and he's going to show us what we can do with this data.
All right, so here, I got everybody's data here. It's all collected. We could do a lot of things with these M&Ms, right? And I think this is a really fun experiment because obviously everybody likes candy. So I think it's really nice to have an example that involves candy. But we can see here sort of the distribution of the colors between everybody's bags, right? And we can see that some people's bags aren't like other people's bags, right? So for example, in Allison's bag, right, she has a lot of blue M&Ms and a lot of orange M&Ms, not too many red M&Ms, right? But we go to Sophia, or we go to Isabel's bag, and she has a lot of red M&Ms and not that many blue M&Ms, right? So we can see that these colors are going to vary based off of bag or based off of person, right? Now, you might think that the M&M company should give the same amount of M&Ms per bag, or that the M&M company should be giving the same number of colors in every bag, right? But these companies, if you think about them, they're not like hand-picking every color and putting them into a bag and so shipping that bag across the United States. They're having a machine just sort them out and just putting a specific number in a bag and just shipping it out that way. And so there can be some variation, right? And you can see in this example that some people's bags have more colors of a specific color and less of another, or even the fact that these bags are all going to be varied in terms of number of M&Ms, right? Some people have 32 M&Ms. Most people have about somewhere like in the high 20s. And then we have, some other values for these numbers too, right? If we expected them, right, ideally we'd expect these to all be the same number, but we can see that they're going to be a little bit varied by person to person or bag to bag. And so what we're going to do here is just graph essentially the things you've learned, a pie chart and a bar chart of the different distributions of colors. And so that's what I have here. I put all the colors into the software that I use to create these figures. And then I was able to create a pie chart and a bar chart, and I put them next to each other. Right, so this is what we have at the end of the day, right? So we have all the colors. So we have the 73 blue, the 30 brown, the 48 green, the 43 orange, the 78 red, and the 48 yellow all onto this figure.
So I could see the red one is higher.
So you can see that red has the most colors, right? Oh.
The least color is brown, so that means not that many people had that much brown.
Yeah, those are really great observations. Yeah, so you can see based off of this figure that red has the most and then brown has the least.
Everybody, please say thank you first to Dr. Eric for coming to talk to us today.
Thank you, Dr. Eric.
Thank
you,
Dr.
Nice. Of course, you're very, very welcome.